Alright, hi everyone. This is Codeforces round 1109, Division 3. I'm going to be virtualing it, and Screencast. He took a row and drew horizontal lines on it. Okay. Asterisk denotes an empty part of the paper. Character this denotes 1 centimeter of a drawn line. Forms a single line. Okay. One. 4, 0, 1, 3. Right end of the line reads 1 centimeter for the left end. Choose a line. So int L is 0, right there. Int I is 0, like that, this plus. If Si is equal to this, L plus plus, else L is equal to 0, enter equals max enter, L plus 1 divided by 2, int enter 0, enter equals max enter, L plus 1 divided by 2, enter. Next problem. Okay, so int n, scene n, have a vector. Arrange splits into n stacks in a row, number 1 to n from left to right. I stack contains AI books. Neat if in every stack except for rightmost one, the number of books strictly less in the stack to its right. Okay, so strictly increasing. Okay, choose a stack I and get rid of 1. Take one book and give it to AI plus 1. Okay, so strictly increasing. Um, just try to make it 1, 2, 3, right? Long ramp is 0. Point high is 0. And I plus plus if 8 is greater than 9 plus 1. Round plus equal to 8, 9 minus I plus 1. Otherwise, right? Ramp minus equal to I plus 1 minus 8I. If RAM is less than 0, we can just spell no and in return. Otherwise, the answer will be yes. This one, and x and y, vector in P. Okay. Permutation P of length n, P sorted, okay. Choose indices and swap the elements P and Pj if at least one of the following conditions holds. Okay, so think DSU. Uh, yeah, I think we can use a DSU here, right? Um, basically, you have our string sets DSU for n. For int at 0, I smart n at plus if I plus x is less than n, DSU dot unite I plus x. If I plus y is less than n, DSU dot unite I plus y. Okay. So for every index we have so 1, 3, 5, and 2, 4. Okay. Vector int values. Okay. So for 0 is smaller than n, I plus plus vals dsu dot find I push back key of auto and v vals sort of v. Okay. Now for every position, we can do greater. For every position, you have a int cred. Int cur will be vals dsu dot find I back if cur is less than cred. Output no return. Cred is equal to cur val dsu dot find I dot pop back. And then output yes. Alright. So next problem. You have n and m. Vector int ai. Okay, so and bm. What do we have, right? Array A of length n to be a negative, is watch short video, positive it works. Okay, the sum of all values in an array. Sometimes he reads motivated posts, gets m posts, where j has the impact value of bj. Beginning of the day up to position bi, change sign. All are multiplied by -1. Okay, so reads a post of value 3, and sign the first 3 elements are flipped. Maximum total productivity, right? So basically, we can flip the signs of some length of the beginnings, right? Okay, so if we flip 1 and then over here and then over here. So if we flip 5 over here. Okay, so just sort them in decreasing order. Int count is 0. 4 implies 1, 0, and minus. You have int j is equal to -1. Int j is 0. If j is less than m and bj is equal to I, bj equals I plus 1, c and t equals 1, okay. And bj equals I plus 1 if AI is less than 0, if AI is less than 0, and count, less than 0 and count is equal to 0, or AI is greater than 0. Yeah. We can use a DP because DPN is GPN minus 1, 0, plus equal to AI, GPN minus 1, 1, minus equal to AI, J plus plus. So count can be flipped, right? So basically DPN minus 0, X DPN minus 1, 0, DPI 0. So DP is I plus 1, I plus 1 is 0, E plus 1 1, plus minus 8 5. So if count is 1, and then we flip it, right? So we flip everything here, okay? And DP 1, DP 1, DP I plus 1 0, minus 8i, and then have our answer. So answer equals max DP 0 0, DP 0 1, output answer. Let's see over here. We got 15. So we flip it from index 2. And it should be negative 5, right? So pi 0 plus equal to ai, so it's negative 5. Okay, so starting from 2, we have negative 5, negative 5, negative 5, and 5. So dpi1, dpn1 should be equal to 1 and 18. And we need long numbers. Yeah, because dpn1 is not possible at the beginning. Right? To be 0. Okay, negative 1 and 18. 6, 5, 4, 3. Okay. Wrong answer on test 3. So let's see. use long one for answer. Schooling. I'm doing, how am I doing? Okay. Doing pretty good actually. Alright. So, but I got a penalty time for that. Sorry. Master and a garland. Okay, so int and q. String s. Int. Let's see what problem this is saying. Each bulb can be either off or on. The state is given by binary string s. 0 is off, 1 is on. Beautiful if the states of adjacent bulbs strictly alternate. Okay. Choose a subsegment and flip the state of all bulbs in it. Turn all bulbs on, all bulbs off. Okay. Some L to R bulb inclusive must make the sun beautiful. I'm not sure where this is always possible. Games are independent. Okay, so you must use at most k operations to change a part of the string beautiful. 1, 5, it's 1. So we can just change this over here, right? 1, 0. So there's an easy brute force solution. Okay. What about we can use a prefix, right? Pref is 0, so basically it starts at 0, and a pref 1. So it starts at 1. Okay. Or a times 0, smaller than n plus plus. If si is equal to 0, okay. So p0 I so so if si is equal to 0 and I mod 2 is equal to 0, p1 I plus plus. Okay. Um if and then otherwise it's p0 I plus plus. So they need changing in this else I mod 2 is equal to 0. P0 I plus 1 plus else P0 I plus 1 plus P1. Okay. Int pre is equal to 0. Pre is negative 1. Pre is 1. Pre is 0. Pre is 0. Pre is 1. Plus equal to pre is equal to pre is not equal to 1. Plus equal to pre is not equal to 0. Plus equal to pre is not equal to 0. Plus equal to pre is not equal to 1. And now we can calculate so p0 I plus 1 plus equal to p0 I and p1 I plus 1 plus equal to p1. Okay. And we can just output, right? So int min p0 r minus p0 l minus 1 p1 r minus p1 l minus 1. If min is less than or equal to k, you can just output yes. Otherwise we output no, and we output a and expected no found yes, fifth of them. 340. 3 4 is over here, right? So 4 is 1, and then here 0. Previous 0, previous 1. Okay. Zero, 0, right? And then 0, 1. 1, 1. Okay. Yeah, 1, 1. No. 0, 1, 0. So it's still 1. Oh, still 1. And then 4 is 0, 1, 0, 1. Okay. So basically no change over here. P1 plus plus. 0, 1, 0, 1. 0, 1, 0, 1, 0. Okay. So operations over here. So once you get to here, this is 0, 1, 2, 3, 4. 4 minus 2, right? 0, 1, 2. So we get 0. Okay. So basically, 0, 1 forms a continuous track. So if it's 1 over here, well, basically we need 1 more. Here's 1 move, and then here is 1 move also. Previous, right, 0. So we need a move over here. 0, L minus 1. Curve down, all P0. Okay, so let's see. I'm gonna have to use a map. P0 is 0. It's 0, and P1, 0 is equal to 0. Okay, and MP0, P0 plus 1 is equal to I plus 1, and P1, P1 plus 1 is equal to I plus 1, plus MP0, um, P0 L minus 1 less than L. Yeah, right, if this is less than L, then, okay, plus M, yeah, 1, P1, L minus 1 is less than L. So yes. 3, 4, so 0, 1, 2, minus 1. Basically, I don't even need to map it. 151 plus P0L not equal to P0L minus 1. So if they're equal, right? P1L is equal to P1L minus 1. We don't need the maps. So 1, 5. Let's learn test 2. Let's see. P0R minus P0R minus 1. Here, that's the total. So starting here, we need 1, right? 0. If it's 0, we need 1. P0R minus P0L minus 1 plus P0L equals P0L minus 1. For 3, 4. 0, 1, 2, 3, and 4. So we consider both 1s, right? 4, we need 1 over here. 1 minus 1 plus. If we need an extra 1 over here. Not sure where this is. Alright, so we make prefixes. Something like, let's just do 4. 0, 1, 1, 0. Okay. Okay, so first let's write 1, 1. Right. We need 1, 1K. So we have a test case, right? And then we have 4 and 10. The string S consisting of zeros and 1. Scaling is L, R, and K. So 1, 1, and 1. 1, 0. Okay. 1, 2, and 1. 1, 3, and 1. 1, 3, and 0. 1, 4, and 2. 1, 4, and 1. Okay. 2, 4, and 0. 2, 4, and 1. Right. So we start from L minus 1. We go all the way to R. E1, R minus 1. So P0 R, P1 R. Okay. Right, this bridge should work. Let's see. Where was the group? Test generator in wait. Generator, right? So hmm, we automatically generate a random to 2. Yellow and line. We have n, right? So n values. Int L random from 1 to n. R random L plus 1 to n. No, from L to n. Okay. Node K is random from 0 to n. Um, L, R, and K. Error. Wow. So randomly from 1 to n. So 0 to right. Having random n. Oh, having n and q. Changes to a 10, which is so it looks better. So 440. 440 should be yes, because we have a 4 and a 4 and 0, okay? We got no. Just copy this test. So, okay. If we need 0, 1, 0, 1, right? So maybe like 2, 4, 4. If they're equal, they're equal, just self it, yes. So, still wrong answers. What test was that? Let's see, right? So 1 and is much this 8, 9, 9 and 9. I forgot to update, but 8, 9 should be correct. Okay. Output 0. 8, 9, and 0. What happened to 8, 9, 0? In 8, 9, 0, this is 9, and then minus 7. It's better to do 0, 1, so 1, 0, 1, 0, 1, 0, 1. Okay. So you start over here 1. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 8. 9 and 8. Okay. So, and because we have these two are equal, we added 1. But we're not supposed to add 1 because it's fine already. Okay. Plus if L is not fine. So S minus 1 equals 0 plus L 2. So again, 0. Wait, hold on. Let's see. 0, 0. Q. while Q minus minus LRK. Uh, what? Do we not output anything or what? In 222, we didn't go over here. Oh, yep. Eight equals one. Sure. Maybe pass. So, just to make sure. Okay. Most okay. We didn't do too well. Alright, next problem. On your left trees. Okay, so 8n, the parent. How to probably construct an adjacency list. You would tree with the root at vertex 1. The leaves of the tree contains integers from 1 to k, where k is the number of leaves. Okay. Each leaf contains exactly one number. For every vertex, its children are ordered from left to right in increasing order of their indices. If we list the leaves from left to right, their values form a sequence. It wants this sequence to become strictly increasing. Uh, Choose any vertex and cyclically shift its children to the left. 1, 2, 3, it will become 2, 3, 1. Can be applied to any vertices any number of times. Okay. The leaves contain integers from 1 to k. Okay, vector into A. Oh, vector into adjacency list. ADJ, PI, pushback. Okay. 5, 5, 2, 1, 1, 2, 2. So you can shift them. Okay, so you shift them. Um, Basically just ask if you can shift it so it's sorted, right? Okay, so you can find the leaves. So over here, if you go to node 5, you can shift these two also, right? But yeah, so if we choose 5, we can also shift 7 and 6. 3 DP, right? So we start at 6. Let's see. Let's go to this one, right? Graph editor. So 1 and 5. Um, Now 2 and 5. 3 and 5. 4 and 2. And 5 and 1. Alright, so in this tree, okay. What about 0, 0, okay, 1, 2. So 1 and 2. Yeah, so like in this case, you can just do that, right? Okay. What about here? So 2, 1, 3. So it cannot be shifted. Okay. And then shift these two, and then we'll be fine. So sheet so sort and give indices, and then you can check. Okay. So leaves. Have just many number of leaves. The vector ain't um fast. Okay. Right. Next, a adjacency curve. Alright, that's just your children, so DFS next. 80 Drake empty vowels pushback. Okay. The pushback. What is the pushback? Just A of current, right? Okay. DFS next. Vector code code let's write C dot pushback vowels. Int net. Okay. Vowels. And we don't need vowels next anymore. So we can just clear it. Just so we can save memory. So vector and copy to C sort of CPY running to I is 0, last one than CPY size plus MP CPY equal to I for auto and V and C and valves dot pushback and PV. Okay, so now we're just asked if it can be sorted, right? For any value, it will be 2, 3, for example, 2, 3, 0, 1. Basically, two of the values will be non-increasing. That's it. So, into CNT is equal to 0. Current I is 0, I smaller than new valve. Size minus 1, I plus. CNT plus equal to new valve I greater than new valves I plus 1. If CNT is greater than 1, output no. Okay, it's 1. Okay, it's 0. Return 0. Return. Okay, yes. Else, output no. Two, okay. Four yeses over here. 2, 1, 3. Alright, so it should be 2, 1, and 3. So 1, 2, 3. Bathroom tests. Did we forgot to update files, right? C dot pushback events. Okay, so we never updated the valves cert. So that's a problem. Okay, so valves cert. This should just be a vector of all the things, right? Okay. For all MP map. For auto indexing, MP dot first. Valves cert dot pushback X. Okay, let's get a big example. Right, so so 1, 2, 3. 2 can go in. One. So what values does this work, right? 2, 3. I think what we should do is we should add an extra test. So the vectors themselves have to be able to be sorted also. So valves correct. If vector int temp is equal to valves cur, sort all temp. If temp is not equal to valves cur, okay, 0, and we can return. Yeah, because it has to be sorted. Memory limit, I thought I had cleared it. refactoring C. Yes. Pointer. It was made serious. Be a pointer. So okay. or first and x plus rest push back um, sort complete. Oh no, we did sort. Okay, did sort CPY. Rest dot at I is greater than rest dot at plus one. Um, okay, 0. Reference to local variable. U to DS. For vector int, right? So it's just basically update this. Uh, okay, I think this is okay. Moving on test two. Uh, where is my code field? Just return vector ints. Okay, so we can rotate these, right? Yeah, I can rotate these. Um, don't know why does this fail? So over here, okay, so the thing is, after you sort them, they can only be in that position. All of them have to move at the exact same time. Okay, all of those vectors have to move at the same time. Um, okay. Basically, we need less memory. It's like, I think, how about this? We can just pass a reference to a index. So if there's only one child, basically what I'm thinking is we just can return it, right? Okay. Acre. Pushback balance next. C dot pushback values. So what I think we can do. I'm gonna go to G first. Okay, so yours and homework assignments. For each assignment, its weight A is unknown, is known. The number of course points Ira will receive if he completes it. Okay. He wants to choose a subset of assignments to maximize the total number of points. However, he has one problem. Some assignments are too time consuming. If Ira works on two assignments at positions I and J, I is not equal to J, there must be enough other assignments between them. Otherwise, he will get too distracted and fail to complete them. Okay. Formally, for any two chosen assignments with indices I and j, the following condition must hold. Absolute value of I minus j is greater than max of a I and aj. Okay. Find the maximum total weight you can obtain by choosing a subset of assignments satisfying the condition. This is dp, right? I and j. So max ai, aj. Okay. It's probably dp with some other trait. So, okay, yeah, I'm just gonna stop here. Um, go over my solutions. Okay, alright, so problem A basically is just, if you have a sequence of, uh, lines, right? For example, you have, right? If you have four of these, then you need 2 times to erase it, right? So 1, 2, and 1, 2 over here. But if you have 5, then you'll need 3, right? If you have 6, you also need 3. So basically, it's just the ceiling of the length divided by 2. Um, so basically, all I did was I looped over, I solved the length of the current segment, and then just answer equals max answer, L plus 1 divided by 2. Because just shorthand for the ceiling of L divided by 2. In the end, you also have to do this, and then you can just output your answer, right? So, pretty simple. Okay, next problem. Okay. So this one is like it's just you gotta use a remaining, right? How much is remaining um to use, right? If AI is greater than or equal to I plus one, we can add to this remaining because basically we subtract from AI, we keep subtracting from AI and keep adding from AI plus one. Because our goal is to make it all strictly increasing, so we can just turn it into one, two, three, four, five, and so on, right? Just because this would cause them to have the most increase. Um, okay, so otherwise, right, if it's not equal, so it's less, RAM minus equal to I plus 1 minus AI. If at any point the remaining is less than 0, we can output no, because it's just not possible. Otherwise, in the end, we can output yes. Okay, so next one, problem C. Okay, problem C, just use a DSE, right? When you see this problem, basically, um, for any I and j with distance x or distance y, you can swap the elements. So you can swap any elements that are connected in the DSU. So you have a DSU, right? For every I, if I plus x less than n, we can unite I and I plus x. If I plus y is less than n, you can unite I and I plus y. And then you have your values. And over here is just implementation, right? So you find the cycles, you put them values, right? You sort all of them also. And then for every index, you check if you can put it if like the final array will be sorted for putting in this element. And yeah, um, so this is just normal checking. There was a problem some time ago in another division 3 that also uses technique. So yeah. Um, Next one for D. Okay. For D is a DP, right? So first I sort all of B in decreasing order. So now it's 2 pointers plus a DP. For a DP, right, first just DP n plus 1 and vector long long 2. I go from back to front because if you have a B, right, for every B, you have an index. For example, right now it's at 5. If you use the negative, if you use the operation over here, and then you go to previous, you go to the next element, this element just stays the same forever. It will not be updated. So DP from back to front is good over here. So I have a DP over here, right? For currently DP n 0 is 0 and DP n 1 is negative 118 because you can't reach DP n 1 at this point. So for every index in A from back to front, so basically right now it's the previous, right? And DP I0 plus equal to AI, DP I1 minus equal to AI, right? Those are just the operations. One just means that we have the operation is in use already. So you have to negate the current value. Now we use 2 pointers, right? If j is less than m and bj is equal to I plus 1, so basically check if we can use the operation right now. If we can, right, just update dpi0 and dpi1. So dpi0 will be the max of the current value, and dpi plus 1, 1 plus ai. And then dpi1 will be max dpi1, dpi plus 1, 0 minus ai. And then we just let our answer be the max of dp0, 0 and dp0, 1. We can output our answer. So also simple, right? So problem E, basically, when you see the problem, basically I think of a prefix sums. So basically P0 means it's 0, 1, 0, 1, 0, 1, 0, 1. right? P1 is just 1 0 1 0 1 0 1 0 1 0, right? Um, so P0 and P1 basically are DP values for um, how many operations you need to get to so that indexes 0 all the way to I are okay. Or 1 all the way to I are okay. So you just calculate this over here. It's pretty simple, right? Okay. And then once you go to the queries, you have L, R, and K. So basically, just calculate how many operations you need for L to R, right? So I use a stress test. I'm not sure, really sure why this works, but um, it works. So I just added it in there. Int min, right? It's just P0R minus P0L minus 1 plus if the current value is okay, if the value at L is okay, and P1R minus P1L minus 1 plus if the current value at L is okay for P1. And then if this is less than or equal to operation, output yes, otherwise output no. Okay. And because this is more of a just me solving it, I think I will just ask AI really quick how to make this memory better. Um, make this more memory efficient. Okay, let's see what is this. Wait, was that my submission over here? I don't think so. I need this code. Okay. Probably something about small to large merging. Use move instead of copying. Oh, so move is O1. Okay. Um, each map node allocates memory to store a full copy of vector. Instead, we can create an array of indices, or just sort these indices based on the values in C. Okay. And late we're gonna copies. Okay. Let's see, right? So use move. Is it just set up pushback move? Okay. Set up pushback move. And you have your indexes. So you sort your indexes. Basically just new vowels. Right, yeah. Um, wait. Sort indices instead of creating a deep copy and using heavy map, complete map logic duplicates to the highest index of their identical group. Okay, I'm gonna copy this over here. Okay. Repeat the map logic duplicates to the highest index of your identical group. So 2 pointers. Okay. Int count is go. So this is the same thing I just did. Insert unique vectors, get duplicates, that's map did. Okay. Oh, and you can use this sorted. That's a thing. Oh, okay, that actually is a thing. Okay. Um, okay. Okay, yeah, I see. Okay. Um, I'll just write help from Jim. Okay, so I'll just submit this after the contest ends and see how it goes. Um, yeah, this is memory efficient, I think. Um, calculate the complexity of this, of the memory complexity of this code. OM. Uh, exactly one element. Move. So, okay, so OM space complexity. Just using move and then we can get ON complexity. Okay, that's nice. Alright, okay, so this is virtual contest. Did okay. Did okay for the first few because I did them like pretty fast actually. See. Okay, yeah, so the first few I did pretty fast actually. Okay. Yeah, so I'm gonna end this video here. Yeah, okay. Bye.